Hi, Hi everyone. We are starting the video 11 on linear programming, and our goal is really to find the best solution when several conditions have to be met so that we can be able to solve real-world problems. Alright, so having said that, let's talk briefly about what linear programming is all about. So when we're looking at problems in real life, we're really always concerned with obtaining the best result given certain constraints. In the business world, so people would like to either maximize profits or minimize losses, and when we're looking in production, people are interested in maximizing productivity and minimizing costs. However, there's always going to be some sort of constraints. So there could be a constraint, it could be referring to the amount of money that you have available in your budget, or the number of people that you're allowed to hire, the amount of space you may have, the production capacity, all these things. Okay, so linear programming deals with this type of problem using inequalities and graphical solution methods. Okay, so having said that, the best way to go about solving these types of questions is really just by doing them. So we're going to start with a question that's relatively easy, but we're going to go step by step here, and we're going to try to figure out what we're going to be doing. So basically, you're going to be just given the word problem. So here's a word problem on a business application. Claire owns a quilting store, and in addition to quilting supplies, she stocks queen size and baby quilts. She wants to order up to 50 quilts to display and sell this fall, and she knows that she has to have at least as many queen-size quilts as baby quilts. And she wants to have at least 10 baby quilts. So it says make a graph to show the possible combinations of quilts that she could order. Alright, so the first thing we need to do is, because we don't have any information other than she has to order up to 50 quilts, and she's going to have as many queen-size quilts as baby quilts. Those are all the constraints that we're looking at. So we are going to have to take out the constraints from the word problem. So the first part we want to do is express each constraint as an inequality. So we need to get down our inequalities. Now, up till now, we have been given all the inequalities, and then we have graphed them. We have found the feasible region. We have used the corner points to find our maximum profit or our minimum losses and so forth. Now we are starting straight from scratch. And starting straight from scratch means that you are just given the word problem, and we are going to have to come up with the constraints from the word problem. Okay, and then graph them. Alright, so let's start with making a graph to show the possible combinations of quilts that she could order. So if we go back to the question, the first constraint is certainly going to be that she wants to order up to 50 quilts. So up to means up to and including, so we don't want more than 50 quilts. So we could say that X is going to be the number of queen-size quilts or covers, and the Y is going to be the number of baby quilts. So if my first constraint is that she has to order up to 50 quilts, then I could say that the combination of the two, X plus Y, the queen size quilts and the baby size quilts, X plus Y has to be less than or equal to 50. That would be my first constraint. Okay? The second constraint, as I go along, alright, says that she knows she should have at least as many queen-size quilts as baby quilts. So at least means that she should have at least as many queen-size as baby. So if we said that the queen-size quilts are X, then X is going to have to be greater than or equal to Y. Or another way of writing that, which is exactly the same thing, would be Y has to be less than or equal to X. Okay, so there's my second constraint right there. So she has to have at least as many queen-size quilts as baby quilts. And our third constraint is going to have to be that she wants to have at least 10 baby quilts. So at least 10 baby quilts is going to have to be Y has to be greater than or equal to 10. All right, so having done that, okay, what is left for us to do at this point is that now that we have our three constraints, we have three constraints here, we're going to now go on and graph those. So I'm going to graph x plus y is less than or equal to 50, y is less than or equal to x, or y is greater than or equal to 10. So in graphing x plus y is less than or equal to 50, that means that I'm going to change this into the y equals mx plus b format, so that y is less than or equal to negative x plus 50. And in saying that, I know that my y-intercept is found at 50, so there's my y-intercept, b, and I know that my slope is negative 1, or negative 1 over 1. So I will start by placing, I'm going to go up by 10s here along my y, because I know my y-intercept is at 50, and I'm going to also go up by 10s in my, so I'll have my baby quilts off on my y, and my queen size quilts on the x. And that's simply because we called x the queen size quilts. We had said that was the queen size quilts, and we called the y the baby quilts. Okay? Alright, so that when I graph, I'm going to have 50 is my y-intercept, and technically I would be going down 1 unit and 1 to the right, down 1 unit and down to the right, down 1 unit and 1 to the right. Now, rather than using that method, my idea would be to get the x and y intercepts to get the line. Now this is something you definitely did last year because I've heard you talk about it in class. So what we do is to get the 2 points, to get 2 points on the graph, rather than getting the y-intercept and then getting and moving down 1 and 1 to the right, down 1 and 1 to the right, how about if I find my x-intercepts, which is here, and my y-intercept there, which I already know to be 50. So to get the x-intercept, I let y equal 0. So 0 is less than or equal to negative x plus 50, so x has to be less than or equal to 50. So I know that my point for x is 50 and 0. So I'm going to graph 50 and 0 here, okay, which I'm coloring in right now in blue. And then my second point is my y-intercept, which we already know to be 0 and 50. And then I can make a straight line through those two, and that's my first graph. Okay. Now, because it has to be less than, because that's got to be less than, then I'm going to be graphing the underneath part. So the underneath part is all this area down here that I'm coloring in right now. Okay. So I just colored that in, but I'm going to remove it just for to make it more visible. Okay. So, however, I show you that the bottom part or the underneath that line is your less than. The next line you're going to graph is the y is less than or equal to x. Well, the y equals x line is the red line, okay? And y equals x is going to be, for every value of x, I get the same value of y. So if I choose 10 for my value of x, then y has to be 10. If I choose 20 for my value of x, y has to be 20 as well, and so forth. So I have a straight line going across there, okay? And then my third line is y has to be larger than or equal to 10. So if y has to be larger than or equal to 10, then that's a horizontal line, which is my green line. And therefore, if it's larger than or greater than, then what's going to get colored in is above. And what got colored in the previous, in the red line, was underneath. So all these areas were colored in before as such. So that the area that was common to all three of them now is going to be the triangle that is colored in blue or purple now. Okay? That is your feasible region. Alright? So I took my constraints, I graphed them, okay, and I graphed them by the first point by using the x and y intercepts. The second one was self-evident. It was very clear to graph, and you graphed and you had to color in the area underneath. And then the third graph, again, you had to color in the area that was above on the horizontal line, y is greater than or equal to 10. And looking at that, we see now that the points that are given are 10, 10, then we've got 40, 10, and we've got and then we've got another point, 25, 25. All right, so those are our 3 points. Now, if I go back to the previous page for a second, I'm just going to read what, so we've taken care of part A. We made the graph and we showed all the possible combinations of quilts that she could order, okay? And that combination of quilts that she could order are all inside the feasible region. This is the region that has all the possible combinations of numbers of quilts that she could order, okay? So, having said that, we move on to part B. Now, part B tells us that suppose that Claire prices her quilts so as to make a profit of $100 on every queen-size quilt and $35 on every baby quilt. Now, given the constraints above, how many quilts of each type should she order to maximize her profit? All right, so the first thing I'm going to do is I'm going to write out my profit function, my profit equation, because they didn't give it to us. Contrary to previous problems we had done in practice 45 and so forth, we were given in those questions all the profit equations. Here we have to make our profit equation based on the information that's given in the question. Okay, so we know that profit is equal to 100x plus 35y. So I'm going to go to 100x plus 35y, and these are the 3 points that we placed in there. Okay, so we will place in there 100 times 10 for the value of x plus 35 times 10 for the value of y, and we get 1,350. And then we're going to do exactly the same thing, replacing in there 25 and 25, and then we'll do exactly the same thing, replacing the value of 40 for x and 10 for y, where we'll get then 4,350. So when we when we add all this up, and we get 1,350 for the first combination, we get 3,375 for the second combination, 4,350 for the third combination. If we are trying to maximize for profit, then we're going to order 40 queen-size quilts and 10 baby quilts. Okay? So that we know 40 queen-size and 10 baby blankets. Quilts is referring to blankets, by the way. So 40 queen-size blankets and 10 baby-size blankets are going to give her the best profit in terms of combinations of what blankets to buy. Okay? That should take care of one example. All right, let's move on to a second example. Now, in this second example, I'm going to read the question to you, and what I'm going to ask you to do is I will ask you to write down the 3 possible constraints that are here. Okay? So I'll read the question with you, and I'm going to ask you to do the 3 constraints, and then I'm going to end the lesson right here, and we will continue with this next week during class, either period 2 on Monday or period 6 on Tuesday. All right, so Julian and Yoshi, this is a consumer economics application, and we have that Julian and Yoshi are making punch for a party using papaya juice and apple juice. And they want to make between 12 quarts and 15 quarts of the punch. They want to make between 12 quarts and 15 quarts of punch. They know from experience that there should be at least twice as much, but not more than 3 times as much apple juice as papaya juice. And we know that apple juice costs $2.49 per quart, and papaya juice costs $1.53 per quart. So the question is, how much apple juice and papaya juice should they buy to maximize the cost of the punch? So what I'm going to ask you to do right now is I want you to think through this problem and read it. You're going to have to read it, reread it, and reread it again. And I want you to think about what the 3 constraints are going to be that you're going to be graphing eventually in class. You're not going to do it right now, but we will do it in class together. But I want you to come up with the 3 constraints. And then I'm going to end it at that. And I'll see you on the next lesson.